Okay, well, thanks a lot for being here today. It's a pleasure to have you here, and for us to be here as well in this place, which for me is really the temple of wireless communications, Qualcomm. I, as a young graduate, interviewed here a while back. That was back in 1999. What a grueling experience, going through all the like going from person to person for the interview and getting grilled. Quite an experience. But yes, Qualcomm has got this special place in our hearts. All of people from those times when 2G and 3G was happening, and yeah. So my name is Irfan Gauri. I represent the OpenAirInterface Software Alliance in the capacity of Director of Operations, and I've been in touch with most of you for many different things. So again, thanks Qualcomm for hosting us here in this very first presence on the West Coast. I'd like to formally open the workshop by giving the floor to Ed to welcome us, Ed Tiedemann, who's a well-known figure in wireless communications. He's an IEEE fellow and a Qualcomm fellow, and also a senior vice president of engineering at Qualcomm. He is heading the standardization activities of Qualcomm and also industry organization activities. And I believe he's been with Qualcomm for a very long time. He's been instrumental in CDMA 1 times, the building of that standard and that technology. I feel a very personal connection to Ed, even though he may not know it. There was another of our professors at EURECOM in the south of France, Pierre Ramblay, who was also an MIT professor. Ed had research collaboration links with him. And I, as a young student, was one of his teaching assistants. So, there's this personal linkage that I feel. Welcome, Ed. And yeah, please.
Okay, that one seems to work. Good morning, all. I'd like to welcome you to Building Q. Okay, this may not mean anything to you, but this is headquarters 5G modems, 4G modems, 3G modems, and part of 2G modems. Okay, we're all developed primarily in this building. This was our headquarters building for quite a few years. I was in this office. This is where we did the 3G designs. The system design for 3G was up in a piece. By the way, this part of the building wasn't there. It was added on somewhat later to get this newer lecture hall facilities and things like that here. But gee, it's a real pleasure having been involved with actually the design and development directly of now everything from 2G, now I'm touching 6G, over many years, and even actually writing some text that ended up being in one of the later versions of the 1G standard. So I sort of covered that entire suite there. What I think is particularly exciting and different today is really the industry effort through such organizations as OAI to really create a platform for research and perhaps reference designs and things like that through OAI and such. For this reason, we've been quite supportive of it as Qualcomm. I think many of you know that we're trying to build our own what we call CSM chipset, which is coming out in pieces, but not in pieces, not broken pieces, but as part of, in parts that we hope will also further the industry quite significantly. In that it will provide I will call it a high performance, lower power consumption platform. And of course, power consumption is really one of the key mantras for the cellular industry today, due to the actual very huge amount of power consumption going on, in that particular industry. And of course, the overall climate issues and all of that, they were all sort of, facing with around the world. But so I think this is really quite, and I must thank and appreciate Eurocom for taking that. By the way, there's quite a connection between Eurocom and Qualcomm. As you said, my thesis advisor when I was at MIT, Pierre Amblay, I never quite understood why he decided to give up a tenured position at MIT and go teach at Eurocom. From that connection, we have gotten actually quite a lot of really great students from Eurocom at Qualcomm, many of which are at the VP, become at the VP level, including a couple of product managers for our entire modem business. Several people who are leading many aspects of 5G and 6G and so on. So it's been quite a run from that perspective there. But I don't know where all of you are from, but other academic institutions. I personally have connections to a handful of them. In fact, I was just at an event at Purdue University. I don't know if there's anybody around from that, which is really trying to develop a new semiconductor program, which is really, really quite important. And they got me on the advisory board of that. We, as a company, as I said, we support research at many, many universities and such. Now, let me turn a little bit to sort of 5G and all of this. And everybody today talks a lot about, research for 6G and all of that. But I want to sort of root ourselves in a little bit of groundness on 5G. We did a tremendous amount of in the 5G standards, 3GPP, release 15 being the first version, 16 where we really incorporated a lot of what we call ultra reliable low latency communications capabilities and such. But the reality is we really just deployed UMBB so far, ultra mobile broadband. So if you remember the great triangle, one vertex of that great triangle there, other than to some extent some of the stuff that's been really a carryover from 4G, and we sort of rebranded as 5G, such as NB-IoT and such. But I think the key thing that I really want to sort of come across here is that really a lot of the new very interesting parts of 5G standards have not yet been deployed. And for us thinking about 6G, really getting the 5G platforms out there, understanding it, even if you're just in the research community, to really understand and apply these platforms to new industries, new use cases, and such, is tremendously valuable to this community. And being able to sort of experiment with and, I'll call it tweak various things and all of that you can sort of do on a platform of this type versus when you get down to everything gets implemented in hardware and things like that is really quite valuable. And then comes up with new ideas, understandings, which can really lead us to what we want to do to really improve things in future 5G releases, but also for 6G. And my view and my hope is that many of you will sort of move off and be able to also work in other communities where we are wanting to and seeing deployment. I mean, just as an example, precision agriculture is one that has had the tremendous interest in very sophisticated communications and using many of the techniques that are things like AI and such. I mean, we now have tractors being with very accurate location. They have very, very accurate mapping of land and things like that. And instead of spraying crops with general herbicides and things like that, they're able to say, oop, that plant there is a weed, that one gets the Roundup. Just that little plant, tremendously reducing the usage of, herbicides and things like that. Similarly for pesticides, where this one little area, has got a little bit of, bugs on it that they don't want. So you just sort of sort of do a more localized treatment versus having to do entire fields with, aircraft spraying things, which again are very inaccurate and all. Saves money for the farmers, but the point is it's using a lot of high technology and communications really to sort of help control all and manage all of this. Very, very important. I've probably said enough. Lots of real stuff going on today. I'll be able to be around here for a few minutes and be in and out all day, but other things will call me. But please welcome to Qualcomm and welcome to where modems are made, as well as everything else in your cell phone and in many other platforms. Thank you.
Thank you, Ed.